Hello friends, welcome back to my channel. Today in this session we are going to learn about how we form different gates using other gates. So yes, many a times in exam we are basically given a particular logical expression and they ask us that form a logical circuit using these type of gates and also express it in a sum of products or product of some form. So we are going to deal those kind of questions today in this session, and this is one of the questions posted by one of my viewers, so I'm going to answer him also through the medium of this video. So let's see what the question is and how we solve this. So we have this question that draw a circuit diagram to form the logical expression a plus b. So x equals to a plus b I've written using NAND gates and express it in SOP form. So we express it in then SOP form. So SOP, as we all know, is sum of products form, and they have told us to form this expression using NAND gates. So just a quick review, NAND is basically not of AND. So this is the AND gate, and when you put this not over here, this not expression, this becomes a NAND gate. Okay, and the particular expression is also again the same, that you write the AND first, which is A dot B, and then you put this negation sign above, so then it becomes the NAND. Now we need to uh, form this expression x equals to a plus b using these types of gates and these logical expressions basically. So now how do I proceed with this question? What is my approach in solving such kind of a question? So in that case, what I do is, first of all, I have this logical expression, I have this NAND gate, and I know very well that A bar bar is A, and similarly, uh, what is this expression? First of all, if I just split this up, I can do so by equating it to A bar plus B bar. Now, A dot B bar is equals to A bar plus B bar. But I need A plus B. Then what will happen if I just write A bar dot B bar bar? This expression. I'll get A bar bar plus B bar bar, and which is A plus B. Okay. So this is what we actually require, right? This is what we actually require. Then that means we need to provide the inputs to this NAND gate. We need to provide the inputs A bar and B bar. So that means there are three steps now. My first step is that I'll have to form A bar. Then I'll have to form B bar, and then finally I'll have to provide these both as inputs to the NAND gate to form this expression. So now, if you just think carefully, to form A bar, you'll require one NAND gate. How? I'll tell you in a short while. And similarly, to form B bar, you'll require one NAND gate. To form A bar dot B bar bar, you'll require another NAND gate. So in total, you'll be requiring three NAND gates. Now, here is how you form the circuit. First of all, if you just provide A input to this NAND gate and provide the same input to the second input portion of this NAND gate, the expression that you'll get is A dot A bar, which is equals to A dot A is A, so A bar. And similarly, if you do the same thing with B over here in another NAND gate, you'll get B bar over here. And then when you provide both these inputs over here in another NAND gate, you'll get this expression, which is A bar dot B bar whole bar, which is equals to basically A bar bar plus B bar bar, which is equals to A plus B, which is the desired expression. So this is the first part. So now we are done with the first part. We have already formed the circuit using NAND gates, and we now know that we require three NAND gates to form this logical expression. Now there was the second part also, that how to form the same expression using how to express the same expression using sum of products form. So my approach to do that is I use the K-map approach. I use K-map for converting it into a particular form. So now how do I do that? First, obviously, I write the expression. It is x equals to a plus b. Then, step 1 is mark the cells representing a plus b equals to 1. Mark the cells wherever this logical expression is true. So, also before that, you need to draw the K-map. So, this is the K-map. Okay. So, you have 4 cells because we have 2 inputs. So, there are what? 4 combinations which can be possible, right? So, because A can either be 0 or 1 and B can also be either 0 or 1. So, there are 4 cells now. And now you need to mark the cells representing A plus B equals to 1 or wherever this A plus B is true. So, now we know that this is an OR expression, and for it to be true, you need at least one of the inputs to be 1. Okay, one of the inputs to be true. So therefore, this only cell 0, 0 will not be 1. All the other cells will be 1, because over here, let me take this color. Yeah, because over here in this cell, what is happening is B is 1. Similarly, in this cell, both A and B are 1. In this cell, A is 1 but B is 0. So therefore, it is 1 in these 3 cells. Okay. So therefore, this this is the K-map which is representing the expression A plus B equals to 1. Now, the second step is you need to write the expression in the required form. In whichever form it is required. It's required in POS or SOP. Now, since it is required in SOP form, I'll write each and every cell over here. I'll express each and every cell over here in the form of inputs A and B. So now this is the point where you need to pay a bit more attention. Over here in the first cell, if you notice, yeah, both A and B are 0. So in logic, when dealing with logical expressions, a true input is represented as, if I say A being true, it is represented as A. And then when I want to represent it as 0, I will represent it as A bar, right? Because 1 bar, negation of 1 is 0. So now if A represents 1, okay, then A bar represents 0. Now similarly over here, both A and B are 0. So therefore, it will be represented as A bar B bar. So A bar B bar represents A equals to 0, B equals to 0 cell. And now when you put A equals to 0 and B equals to 0 over here in this expression, what will happen? You'll get 0 bar dot 0 bar, right? Which is equals to 0 bar is 1 dot 0 bar is 1, 1 dot 1 is 1. So that means basically we are actually developing the logical expressions in such a manner that the cell output becomes 1. Okay, that the cell output becomes 1, because what are we representing? We are representing that this cell is true. Now, so therefore we need to give a logical expression in such a manner that the cell output becomes 1. Okay, but now since 0 0 is not the one logical expression which is true, which comes as output true for A plus B equals to 1, just reverting back to this step where we marked all the cells representing A plus B equals to 1. So these were these 3 cells, 1, 2 and 3. So we'll be just coming up with the logical expressions of these cells, and then we'll be adding them up because it is a sum of products form expression which is required. So in the similar manner, for A equals to 0 and B equals to 1, our logical expression will be A bar, because A is 0, dot B, because B is 1, right? And you now can validate that when I put A equals to 0 over here, what will happen? 0 bar will become 1. So 1 dot 1 will become 1, which is required actually. Now similarly over here, when A is equals to 1 and B equals to 0, our expression would be A dot B bar. And similarly for the last one, when a equals to 1, sorry, a dot b bar. When a equals to 1 and b equals to 1, it will be a dot b. So these are the three terms that will be coming in a logical expression. That is why I have written over here a bar dot b, which is this one, then plus a dot b bar, which is this one, plus a dot b, which is the last one. Now we can also verify whether this sum of products form is actually equivalent to the logical expression for which we have developed it. So the equivalent logical expression is what? It is a plus b. So to verify, this entire thing should come equal to a plus b. That is our goal. So I've also done this verification step. So what do? We just write this expression, this entire thing over here as is. Then we find out the ways of reducing it in a manner that it becomes equal to this. Okay. So now what will I do? I'll choose the first term over here as is, and the last term I'll bring near this, so that I can take b common from here. And now when I take b common, I'm left with a bar plus a, which is 1. So this becomes 1 dot b. Now 1 dot b plus ab bar, then we know this identity, and this ab bar plus b is equals to a plus b. So this is the one which we require, the logical expression for which we had developed this sum of products form. So that means our answer is correct. So hence we have also verified this. So that's all for this session on logical expressions, gates, sum of products form. So I hope you would have enjoyed this video. In case you did, please press the like icon below to support the video. Also, if you are the one who has not subscribed to my channel and would like to see more of such videos or some other videos, you can please suggest those videos in the comment section below and subscribe to my channel, and also press the bell icon so that you get notified with my latest videos. Stay tuned, keep learning. I'll be back with some more such videos, such sessions. Till then, stay safe, stay healthy. Thank you.